The next operation between matrices is going to be matrix multiplication. So if you have two matrices like A and B, given that A is of size M by N, and the second matrix B is of size N by P. Guys, take a look. The number of columns of the first matrix is the same as the number of rows of the second matrix. Then you're allowed to form their product A, B, which is going to be an M by P matrix. Super important. And the entries are defined by Cij. Cij are basically the summation of A sub ik times B sub kj. K starts from 1 to n, and from calculus, you can just easily write it in expanded form. So basically, if you have two matrices and you try to multiply these matrices, if you take the first row, you're going to multiply by the first column. And in general, if you take the ith row and multiply it by the jth column, you're basically finding the dot product between these two vectors. As you remember the dot product, if you have u as a vector a1, a2, an, and v, another vector b1, b2, bn, then you can find the dot product by just multiplying the corresponding components and then add them together to find the dot product. You're basically doing the same thing here. You're taking the row and multiplying by the column one by one and add them together, finding the dot product. So if you have two matrices like E, which has two rows and one column, another matrix like F with one row and two columns, take a look. The number of column of matrix E is the same as the number of row of the second matrix. So basically you can multiply E and F. If you multiply E and F, you're basically taking 1 and multiply 1 by 3, and you're forming the first entry, which is C sub 1 and 1. And then you're going to take 1 and multiply by 4 to form C sub 1 and 2. You're doing the same thing, you're just following the definition. Then you're going to take 2 and multiply by 3 to form C sub 2 and 1. And then finally, you're going to take 2 and multiply by 4 to form C sub 2 and 2. The outcome is a 2 by 2 matrix, as you can see. You could also multiply F and E. If I try to multiply F and E, then I look at the number of columns of the first matrix, which is 2, and the number of rows of the second matrix, which is 2 as well. So I end up with a 1 by 1 matrix. But in this case, you just need to multiply these two, one row and one column, applying the dot product. 3 times 1 plus 2 times 4, which gives you a 1 by 1 matrix with one entry, 11. So in general, if you have a matrix like A with 2 rows and 1 column, and the second matrix 1 row and 2 columns, these are the entries of the multiplication between A and B. For B and A, it's just basically the dot product between them.